Hello everyone and welcome to the second course of Data Structures with Python. I'm Al-Ameen and I'm going to be helping you throughout the practical part of this course. Before we start, I encourage you to go back and review the material for the first course, just to skim it, read it quickly, so that you are up to date and ready to learn. Now, what is a linked list? A linked list is a data structure. In order for us to understand it, we have to look at another data structure, which is the list, the array. As we have learned before, arrays are collections of items that have the same type. So in C++, in Java, and in C#, if you want to create an array, it has to be of the same type. An array of integers, an array of characters, and so on and so forth. In Python, we learned that instead of an array, we have a list, which is a collection of items that can have different types. As an example, if we look here, we're going to see that this list has an integer followed by a character, another integer, a string. We have negative and positive numbers. We have Boolean values, and we might also have another list inside of it. So working with lists, we're going to realize that it is actually very simple. It's very easy. I can access any item that I want directly. X in here, this character is located at index 1. We have index 0, index 1. So I can just specify the index of 1 and reach it. But the problem that we're going to see with arrays or with lists is that whenever I'm inserting something or removing something, there's going to be more processing than I need. What do I mean by that? If we take as an example the letter Y, and I want to insert the letter Y in here between number 1 and the character of X in this position. What must happen now is that I have to insert the Y, then I have to right shift every single element to its right. Same thing is going to happen with removing an item. If I want to remove the X, then I have to delete it and then left shift every single item that is to the right of it. That is going to create a lot of unneeded processing, especially if I'm working with lists or records that have many items, thousands of items, because that means whenever I'm inserting or deleting, which might happen many times, I'm always shifting almost all the items that I have in my list. So how can we resolve that? The idea is to look at those items separately. So instead of looking at 1 and X and 13 and this as a single unit, I'm going to look at them separately. Now, if we look at this example in here, I have 3 integers. I have integer A equals 11, integer B equals 52, and integer C equals 18. It's a normal variable, it's a normal integer. We just specify a value for it. So this is the data for A. This is the data for B. This is the data for C. If I want to create a relationship between them, I can change that a little bit. And that is what we call a node. So a node is going to be the same variable, the same data, but it's going to have an additional pointer. So it's going to be my variable, it's going to have its data and its pointer. So if I want to create a relationship between A and B, I can do the following. I can say A, which has 11, that is its data. The next point, whatever comes after A, is B. And I'm going to point from this pointer in here towards B. Or I can say A, which equals 11, points toward C. So A, then comes C. And I can do that in any way that I want. I can say A is followed by B, which is followed by C. Using this method, each node, each one of those nodes can actually work separately from the others. That means if I want to insert something in here, it's going to be much easier because I can just point to it. Let's take as an example removing an item. If I want to remove the item B in here, all I have to do is say A is pointing towards C. Just remove this pointer. That's it. I deleted B. Thank you so much for listening, and I'm going to see you in the next lecture.